Hello everyone, welcome to the sessions of Computational Mathematics. In this session we are going to discuss predicate and quantifier. Under quantifier we are going to discuss two types of quantifiers, that is universal and existential quantifier. Let's define predicate. A predicate is a statement which contains variables, that is predicate variable, and this predicate may have true or false values depending upon the value of the variable. Example, here P of x is a predicate which represents the statements x is greater than x. Here P of x is predicate and x is the predicate variable. Depending upon the value of x, this P of x statements either take true or false values. If we take x value as 1, then 1 is greater than 1, which is false. So this is an example for our predicate. Next is quantifier. We define our quantifier as, let S be a domain or set and P of x be a predicate on our set S. S is the quantifier to express the extent to which a predicate P of x is true over a range of elements in S. Here we use quantifiers in order to create the propositions called as quantification. Example, P of x is the predicate and S is the set of integers. Here P of x is true only when x is 2 and 3. This is the example for our quantifier. In our quantifier, there are two types. One is universal quantifier and existential quantifier. Let's define universal quantification. It is a quantification of a predicate P of x on domain S. It is defined as, for every x in S, P of x is a true statement. So for each value of our variable, predicate variable x, our statement will take true. It will become true. Such quantification is called as universal quantification. It is represented as like this: for all x which belongs to S, P of x. This is how we symbolically represent it. And the example is, for every natural number n plus 1, n plus 3 is greater than 1. Here n plus 3 greater than 1 represents our predicate and set of all natural number is our set S. So for all values of n, here our predicate will take true as its value. This is the example for our universal quantification. Next is existential quantification. Here we can define our existential quantification as a predicate P of x on a domain set S is, there exists an x in S, P of x is a true statement. For some values of x in a given domain S, P of x is true. That is what our existential quantification. It is represented like this: there exists, or for some x which belongs to S, P of x, or for some x, P of x, like this. Example, the statement x square minus 5x plus 6 is equal to 0 is true only for some values of n, not for all the values of n. So this is the example for our existential quantification. So in this session we discussed predicate, quantifier and universal and existential quantifiers along with the examples. Thank you.